Hi, my name is Natalie Rachel Raphael. So for the Fuzzy Logic mini project, we are doing occupancy detection. So there are three members which are doing this project with me, which are Lim Janglong, Lee Jalok, and Mohammad Ashraf bin Abdul Razak. So for the introduction, occupancy can save energy in the control system of a building. So occupancy has a significant role in application such as heating, cooling, ventilation, and lighting system. So this the dataset that we have taken, there are 8 variables in it, which are date, time, temperature, humidity, light, carbon dioxide, humidity ratio, and occupancy. So this dataset, this occupancy detection dataset, we get from the UCI machine learning repository, which consists of 20,559 datasets. And for the problem statement, we want to know which method is better between the fuzzy C-mean or the hard C-mean. So we would like to see which method is more accurate to cluster this data. And the objective is also the same. We would like to know which method is more accurate between the FCM and HCM. For the fuzzy C-mean, Lee Jalok and I worked together to obtain the accuracy for the fuzzy C-mean for the dataset that we have chosen. So as you can see here, there are two accuracy which are the first cluster and this one is for the second cluster. So the first row above here is for the first cluster, which also there are five different numbers here, which this one is for the temperature, this one is for the humidity, this one is for the light, this one is for the carbon dioxide, and this one is for the humidity ratio. This is for the first cluster, and the second cluster is also the same. This one is for the temperature, the humidity, the light, the carbon dioxide, and the humidity ratio. So let me just explain a little bit about the codes. So for this one, we first initialize the membership matrix. So for this part, we randomize the membership matrix by using this random bracket. So after that, it will just simply take any numbers and it will put into the membership matrix. And then secondly, we use this calculate cluster center so that we can find the actual cluster center. And then because now we have two clusters and two cluster, we have already initialized here. So we will use this method this one to calculate the cluster center. So we do some iteration here and then to get the proper cluster center. And then after that, we update the membership value because just now we already first we randomize it. So now we update the cluster centers that we have already calculated in here. So here now we get the cluster center, and then after that we also get the fuzzy C-mean clustering. And after all this function, we then print out, we then produce the accuracy for the two cluster that we have already initialized.
Hi, I'm Nijana, and Rachel and me will handle the part for FCM. And as usual, we will import several libraries. For example, Panda, Tsunami. Panda is used for to read the CSV file. And for NumMe, here is the example for NumMe, and P to read the array, assign the array. Because we are going to cluster into two classes, which is occupied or not occupied. So K we set as 2, and max iteration is 100. And here we are
My name is
going
Ling
to
Yam Leong, and I'm going to explain about my task in this project. I'm responsible for coding part of HCM model. Before we start, there are some necessary packages we need to import, such as NumPy and Pandas. The most important package is the kmin module from sklearn.cluster. First of all, the dataset was imported as CSV format using panda.readCSV function. This will read the CSV file and store in the data frame, which named trend in our project. The variable trend now store our dataset, which contain 5 features, which are temperature, humidity, light, CO2, humidity ratio, and the output, which is occupancy. The dataset is then separated into two NumPy arrays. The first array contains the dataset that contains all the 5 features, while the second array contains only the output column. After that, we define a variable named kmin to initialize the kmin module with parameter. The parameter is set as number of clusters equal to 2, as we only have 2 outputs for occupancy, which are 1 and 0. This parameter can be modified if more cluster is needed. The first array is then fed into kmin model to produce 2 clusters. The kmin.cluster_center will return the value of cluster center for each feature. For the accuracy measurement, we use the second array and the kmin.predict module. The kmin.predict module will use the cluster center just now to calculate the distance between new data and the training data for each feature. Then, the cluster that has higher similarity will be chosen as the cluster for the new data. By comparing the prediction result and the output column in the second array, we get an accuracy around 94% using this model. This accuracy is calculated using total correct prediction over total number of data.
Hi, my name is Muhammad Ashraf bin Abdul Razak, and I'm going to show you my part in the project. So what I did is to display the graph of the HCM, which is the over here from the coding, which is the temperature, humidity, light, CO2, and occupancy, but times by the same thing. So as you can see here, it displays the second graph, which is to show the train data of 2665 points times by 2 clusters. So if you run, so it will display the graph that I just made. So this is temperature times by temperature times by humidity, which is over here, temperature by light, and vice versa. So as you can see here, there's data spread, which is the blue and the orange. So the blue means 0 occupancy, and also the orange is 1 occupancy. That means 0 is, which means there's no one in the presence in the room, and 1 means there's someone in the room. So as for the second graph, which is the train data, which is consists of 2665 points times by 2 clusters. So I label this with red and black, which are, the red is non-occupancy and the black one is occupancy. So this is the data spread of the graph, and that's all. Thank you.